Alright, we're over here at the foam cutter, and we did a demo, Sparky and John and I, over Saturday at John's. And we didn't have time, or I just sort of overlooked it and we got in a hurry. And what I want to do is cover the material that I intended to do over there with this cutter. So this is sort of the key to the whole cutter. These are the cutting bows. The cutting bows are, the tension on these bows is maintained by this rubber band. And this is SIG free flight rubber. You could use rubber bands, but I like this because it's got a really high elongation. I don't know how to describe it, but it's got a property I like on this bow. This is plate glass right here, and these plate glasses are mounted to just a plate, and these plates are bolted to this frame. So the way this works, as the core is being pulled vertical, these bows of course open and close to follow the airfoil, and as they're opening and closing, they're riding on this plate glass, and the plate glass is, with these ball bearings, is about as frictionless as you can get. And the reason why there's two on each end is because when these bows are being pulled tight with the wing coming through it, they want to rotate. So this bow will want to rotate this way, and this bow will want to rotate this way, sort of torque it. So what happens is, with the glass plate on the top will support this bearing, and the glass plate on the bottom will support the back bearing here. So as the bow wants to torque, as it's being cut, you maintain constant pressure on these ball bearings, either on the bottom glass plate or the top glass plate. And then the trick is, when you set this glass plate up, you want to make sure they're meticulously cleaned, and then put these bolts in, and there's wing nuts that go on the other side. So the trick is to get this thing as free as you can get it, to where it slides back and forth freely, and it doesn't bind, but you want the clearance really tight. So you don't want a lot of clacking up and down. You want a little bit, 10 thousandths or something, I don't know, 15. You got to be a little movement up and down with the bow, but then you want it to where it doesn't bind. You got to make sure before you start cutting a cord that you move these bows all the way from one end to the other, and you don't get any binding. So that's a close-up of how these bows are set up. Let me go over here and I'll give you another look at this end. This is set up on the power side. This is a cord I hooked up, and it's just like bullet connectors down here. So that's how I plug this bow in, these bows. There's a jumper wire down there that shorts the bows out, and then these are hooked up separate, these wires, and it goes down in here. So the power comes through these wires up to this bow here and this bow here, and it's terminated down there with a jumper wire that completes the circuit. And these are just ball bearings. This is 3/16 music wire. You could use drill rod. Anything that'll fit over this music wire or drill rod that you got. If you have 1/4" ID bearing, just get 1/4" rod, it doesn't matter. And then this is just tubing C8 in place just to hold the bearings from sliding off. You could use wheel collars, but I've had this for 15 years and never had to worry about replacing these ball bearings. So these little tension blocks here, there's got a set screw or an Allen screw with a threaded block, and basically the tension on these wires is maintained through this bow. This is really good old growth pine, really tight growth rings. It's good stuff. So the main thing is to get good stuff that won't warp, that you can get some tension on it. So I'll get this thing loaded up, get the templates dialed in, and we'll cut a wing. This part of the cutter sets the span right here. So as the wing is being pulled through the wires, this door is falling towards me. And this is how you set the taper up of the wing. This will be the root since it's moving faster. This will be the tip. And since this is closer to the hinge line, it'll allow this cable to go less distance. So I'm going to get it all dialed in. I play with the ratio between the tip and the root, and I have turnbuckles here to dial it in too. So it takes a few trial and error shots here. I'm going to load the templates on it and then turn this camera back on, and I'll show you the dry run of setting up the templates. So what we got here, I've got the templates in here. I call it the dry run, and I don't know if you can see, but I got weights on the bottom of these templates, and that sort of didn't give you a perfect simulation of what's going to happen, but it keeps enough tension on those templates to pull them straight down to get a good adjustment. So basically, I'm starting out here at the root, and you adjust these cables to where everything's starting at the same spot and it's going to end at the same spot. And then it's time, once you get it adjusted, fine tune it, and then we'll load the foam block in there and hook the power up and be good to go.